Moving further, we have t is equal to 2 pi over omega. Omega is alpha over theta. This is angular acceleration divided by angular displacement. Alright, now I have got something over here. Now just to recap, A is equal to F over M, and A is also is equal to omega square x is equal to kx over M. X goes away, so omega square is equal to k over M. Alright, since omega square is equal to k over M, now F is equal to kx is equal to ma, so k over M would be a over x. Alright, so omega square is equal to k over M, so omega would be root of k over M, and omega square is also equal to a over x, so omega would also be equal to root of a over x. Now as I talked in terms of analogy, same way 2 pi over omega, we talked about 2 pi over omega, and omega is equal to a over x in case of linear situation, but now in case of angular, it is angular acceleration divided by angular displacement. Alright, so that's the analogy. Okay, so t is equal to 2 pi over alpha over theta. Alpha over theta, we already had derived it to be minus c theta over I. Alright, so we just substitute over there c theta over I. We are talking only in terms of magnitude, so we have not considered negative. C theta over I over theta. Alright, over theta, and this theta is this theta. This theta gets cancelled, so what we end up with is 2 pi I over c. So this is formula for torsional oscillation, 2 pi root of I over c. Got to keep in mind for numericals. When we are talking in terms of magnetic vibration, so this was torsional oscillation. Now we are talking in terms of magnetic vibration. Magnetic vibration, again, if we see F is equal to ma is equal to I alpha is equal to now there what video I have presented, there I have taken this as capital M, here I have taken it as mu b theta or mb theta. So if I take I below this becomes the formula for alpha. I is taken below this, so it becomes minus mu b upon I into theta. Alright, so alpha, so here again it is alpha over theta, so here alpha is mu b I into theta, so that's what I substitute over theta. Theta again gets cancelled, as here also theta got cancelled, and what formula we end up with is t is equal to, time period is equal to 2 pi root of I over either mb or mu b. This is magnetic dipole moment, this is magnetic field, moment of inertia. Okay, now here I forgot to say one more thing, that is here we are taking disk, so we know moment of inertia is half mr square. Okay, then again let's visit pendulum, simple pendulum. In case of simple pendulum, this is the situation. In case of simple pendulum, it's simple. T is equal to 2 pi root of L over G, where L is length of pendulum and G is acceleration due to gravity. Now there is another thing called as seconds pendulum. In case of seconds pendulum, time period is 2 seconds. Alright, so 2 is equal to 2 pi root of LS I write because it is seconds pendulum, length of seconds pendulum upon G. Alright, so this goes, this becomes 1. If I square this, then it becomes pi square LS over G is equal to 1. Alright, so if I want to take it in terms of LS, G would go up, pi square would come down, and what we would end up with is LS is equal to G upon pi square. These are three formulae which we have derived. This, and modified version for seconds pendulum is this. So actually, to be precise, 4 formulae are very much essential for our numerical purposes. Alright, so please focus into these formulae. Alright.